The information first framework is, first we have to talk about what it's not. What mainstream science has been telling us the universe is for, give or take, 500 years, definitely for the last 200 or so, is that the universe reality is fundamentally particles and or fields, particles, energy, and space-time. And that those are what lie at the foundation of our material existence. What information first finds is that underlying that is information. And there are many, many aspects, even of fundamental or foundational physics, that point to this. Largely, it's the scientific process that has us in what I call materialism or physicalism, because it's extremely difficult to evaluate something that you can't identify or see or measure. That way lies madness, and I get that. So I don't blame science for the fact that I think we're mistaken about the foundational aspect of reality. And in fact, until the late 1940s, information didn't even mean what it means today. You and I go back in time, 1840, and we ask somebody to define information. They're going to give us something like stuff that's written down and things that are true, right? If we come back to today and go to a technology company and we say, what is information? They're going to define that completely differently. They're going to talk about packets and redundancies and resistance and signal. And so we really didn't even have an understanding of information that would allow it to be applied in the way that my book applies it. It's only really been the last 20 years, maybe 30, that we have even understood information in a way that makes what I'm saying applicable. So I'm not saying science is wrong or is behind. I'm just saying that the scientific process wouldn't really allow itself to get to this point until pretty recently. Information, I think it's got 3 or 4 definitions if we cracked open a dictionary. All of them are true from different perspectives. What I mean when I say information is probably best illustrated by this concept. If you look at quantum mechanics, and we look at something recognizable like the double slit experiment, we're trying to ascertain the position of a particle, really. You fire a proton at the panel that's got 2 slits in it. There's kind of a colloquial interpretation of the double slit experiment, which really has more to do with a similar experiment that was done with light quite a bit before. But light is photons, and so it's not completely dissimilar. But the way that a modern double slit experiment would work is you fire the proton through the panel with 2 slits, and you know you fired 1 proton. But a panel on the other side of that slit reveals that that proton explored many, many paths between where it started and that panel behind the double slit, right? They arrive at representing this by what they call a wave function, similar to what we find when we do this with a flashlight. We find light behaving as a wave. We find the proton behaving wave-like. That, right off the bat, doesn't make any sense. If you fired 1 proton and you've got 30,000 individual dots on that panel on the other side, how is that possible in a universe that we understand, where a particle is a particle? Well, it's because the particle is not a particle, in the sense that a coffee cup is a coffee cup or a pencil is a pencil. The way that my framework sees that is that the truth of the matter is that there is no particle. It's not a particle in the sense that we think of things being things. And the pre-measurement arrangement is informational. The wave is not the particle, it's not the particle in an infinite number of other universes, or any of the other explanations that they've kind of had to manufacture to prop up their understanding. What it is it's the information about the particle, or the particle behavior, the field's particle behavior. It's the information about the particle, where it could be, where it might be, where it may end up, and that the measurement of the particle causes a constraint. We're basically telling the universe, we need a resolution of this thing, and the informational substrate gives us that resolution. In my framework, that shows that quantum mechanics is telling us that underlying the material is information. And there's a lot of other folks in physics and other areas of science who tend to stay to their own domain, and I don't. I don't really have a domain, so I have that luxury. But people like Eric Verlinde, who have been exploring gravity, and he has essentially said that he sees gravity as an informational configuration. My words, not his. It has more to do with information than it does with mass. But I think that everywhere you look, the universe shows us it is more foundationally informational than it is physical.